Hello. 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 Hello.
Hi.
Okay. Sorry about the network connection, but so let me give you the definition for reflection and then the factors on which it depends. So reflection of light. Reflection of light. The bouncing back of light after striking a surface. After striking a surface is called reflection of light, or is known as reflection of light. Let's look at explanation. If you are asked to explain what reflection of light is, this is the explanation. A beam of light travels in straight line in a homogeneous medium. But when it falls on the boundary of another medium, then a part of it bounces back. Bounces back from there in the same medium. From there in the same medium. So the bouncing back of light after striking a surface is known as reflection of light. This is the explanation. A beam of light travels in a straight line in a homogeneous medium, meaning in the same. Please, I'll take a shot and put it, send it to the group. Okay, so it will travel in the same, in a straight line in a homogeneous medium, meaning the same medium. But when it falls, or yes, it hits a boundary of another material, then a part of it bounces back from there in the same medium. Please, are we okay with the explanation?
Yeah, please, I can't see the board well. It's breaking.
I'll take a shot and send it to the group.
Yes, please.
So this is what we are saying. If this is a second medium, medium 2. And then light from, please note that this is medium 1. This is the second medium. I'm sending a shot into the group, that's why. All right, I've done so. So whenever light, okay, is traveling within the first medium, the same medium. So from start to when it hits the second medium, we say the light will travel in a straight line within a homogeneous medium. Okay, so long as the path of the light is within the same medium, we say it is its path will be straight. Now, when it interacts with a second medium or a second boundary, then it will bounce off. Okay, the light will bounce off within the first medium. So this is the incident ray. This is the reflected ray. Now, when we draw a normal, which is always a perpendicular line to the second boundary, we have, this is the normal end. We have a very important observation and reflection where the angle from the normal to the incident ray becomes the angle of incidence I, and then the angle from the normal to the reflected ray becomes the angle of reflection. And by experiment, we realize that the angle of incidence I is always equal to the angle of reflection. Okay, please, are we okay with this? So this is reflection.
Please go back again.
All right, so I've given you the definition of reflection, the bouncing back of light after striking a surface. Then, if you are asked to explain reflection of light, how do you explain? A beam of light travels in a straight line in a homogeneous medium. But when it falls on the boundary of another medium, then a part of the light, okay, bounces back from there in the same medium. So we'll have a part of the light bouncing back from the second medium into the same medium. And that is reflection. That is reflection. Now, the concept of reflection depends on some factors. So let's look at the factors on which reflection would depend on.
Mr. Asia, please, I have a question.
All right.
Mr. Asia, please, I want to ask, if light travels in a straight line, how is it that the incident ray over there, like it's, I don't know, slanted or something? Shouldn't it be like the normal? So when it bounces, when it falls from the mirror, to just go back like the exact same way instead of, I don't know, going in that direction like this, like a V direction.
Ideally, it's supposed to have this path. Is that okay? Ideally, it's supposed to go this path.
Okay.
But because we have a second boundary whose nature is not the same as the first because we have a second medium whose nature is not the same as the first medium, that is why we have part of the light bouncing.
Yeah, please.
Is that okay?
Okay.
So
Yes, please.
it has to go in a straight path, but because
This is breaking.
it will be fine. It's a natural challenge. So because you have a second medium whose nature is different from the first, that is why we have part of it bouncing back within the same medium. Is that okay? Now, the factors on which the extent of reflection depends. Let's look at the factors on which the reflection of light. Let me adjust the screen. Factors.
Have you taken a picture of this one?
Yes, I will. Reflection depends. So the extent of reflection of light depends on one, the nature of the surface. Nature of the surface. So it depends on the nature of the second medium. Okay, the nature of the second or the nature of the surface of the second medium. Or then two, it also depends on how smooth the surface is. So we talk about smoothness of the surface. Okay, it depends on the smoothness of the surface. Now, observation or experiment has revealed that if the surface is highly polished and smooth, you have all the light getting reflected. So, experiments has proven that if the surface is highly polished and smooth, all the incident light is reflected. Okay, so the nature of the surface is the surface. So is it solid? Is it liquid? Is it gas? Okay, so the nature of the surface will determine the extent of reflection. Then the smoothness of the surface. Okay, if the surface is well polished or so smooth, we have a situation of all the incident beam or light getting totally reflected. So these are the factors on which the reflection will depend on. Please, are we fine? Are we okay?
Yes, please.
All right. Let me take a shot and send it to the group, okay?
Thank you.
All right. All right, let's talk about the laws of reflection. Let's talk about the laws of reflection. From our observation, what have you deduced or what have you seen as some of the laws of reflection here? From the diagram, from the explanation, what can you say about the laws of reflection? Nana Jemfo, your hand is up.
Please, the incident ray, reflected ray, and normal are all on the same plane.
Okay, so good. When we look at our diagram, we realize that the incident ray, which is this, the reflected ray, and the normal at the point of incident all lie within the same plane. So they all lie within the same plane, and that is the vertical plane. They are all within the vertical plane. So the first law is that incident ray reflected ray and the normal at the point of incidence all lie in the same plane. Some books would also use all lie in the same place. Then two, what is the second law of reflection observed? Yes. Let me have another contribution from whoever is ready. Okay, Nicole, your hand is up.
The angle of incidence is equal to the angle of reflection.
Okay, so from experiment, and once we are doing light, we can confirm this when you come to school, practical. So from experiment, the angle of incidence, which is the angle from the normal to the incident ray, and then the angle of reflection, which is the angle from the normal to the reflected ray, are equal. Okay, so the second law of reflection is that the angle of incidence is equal to the angle of reflection. So mathematically, you say delta or this angle I is equal to angle R. These are the two main laws of reflection. All right, and both of them can be proven experimentally. All right. Okay, now let's look at types of reflection. Akofala, are you there?
Yes, please.
Mr. Edia,
Hello.
please, I can't see what you've written in the bracket.
Oh. Angle I is equal to angle R.
Thank you.
That's the amplified version. Okay.
Yes, please.
So types of reflection. There are two main types of reflection, namely regular reflection and diffused reflection. So we have regular reflection or what we call as specular reflection. And two, diffused or irregular reflection. So diffuse or irregular reflection.
State, yeah, please, can you take a picture of it and send it to the group?
Okay. Let me quickly do so and get back to you, okay?
Okay.
It's done. So what is regular reflection? Yes, let me solicit views. Where do I?
Yes.
Can you share with us what you know about regular reflection? That is if you have the idea.
Is it like the reflection that happens on mirrors?
You are not far from the truth, but add more ingredients to the soup. Okay, I have more views. Wedua has given us something, more views. Sanam, what is regular reflection?
Sir, please, I have the same view as he.
Okay. I have also seen your contribution. Please give me a second, I'm coming in. Okay, let's continue. So in regular reflection, yes, it occurs on smooth surfaces. So if you have a well-polished surface, let's take this line and then the serrated line behind are there. Smooth or polished surface. If you have a smooth or well-polished surface, and then you have beam of light incidenting on it, beam of light or rays. This is 1. This is 2. This is 3. So we have a beam. Okay, so this is incident beam. You realize I earlier said that in reflection, if the nature of the second surface is such that it is well polished, It is well polished and smooth. Then you have every incident beam being reflected. So because the surface is well polished and smooth, we have every single ray being reflected. So this is reflected beam. Please